How's that? Can you hear me? Can I ask for everybody on the end who has a seat next to them to just move a little bit in so that latecomers have a place to sit? Just move in one seat. As a latecomer often myself, it's a huge gift if you walk in and there's a place to sit. But not too much, because I think they've shut the side doors too, so you're good, you're good. Okay. I'm really, really happy to be here. My talk is entitled, Freedom in My Heart and Everywhere. As Josh said, I've been involved in the free and open source software community for a while. I am the executive director of the GNOME Foundation, and we'll get to some of that a little bit later, which is really cool. And I, for a long time, was a lawyer at the Software Freedom Law Center, resulting in eventually becoming general counsel. And so I had this really lucky opportunity to get to know a lot of folks in the free and open source software community by helping them with all of the crap that they didn't want to deal with. Really, really fun. I've been a free and open source software enthusiast, I'd say, since the 90s. And I'm also a patient. I have a really, really big heart. I actually have a huge heart. So you'd think because I work for a nonprofit, but I actually have an enlarged heart. So I have a condition called hypertrophic cardiomyopathy. I always get a little bit nervous when I talk about that, because I sort of say, you know, my heart's a little broken. But it means that I have, it's not actually. My heart is very thick. And that means that it has a hard time beating. It's a little bit stiff. And it's actually pretty fine. I don't have any symptoms yet. I just have a very high risk of suddenly dying. The term is actually sudden death. That's what the doctors tell you when they say you have HCM and you need to enter into this lifelong treatment. They say you have a high risk of sudden death, which is really terrifying as a patient. I have about a 2 to 3 chance per year of suddenly dying, and that compounds. So I found out about this at age 31, and so over the next decade, it was sort of like a 20 to 30% risk of sudden death. Really, really just a really scary thing to hear, but there is a solution right now, which is to get a defibrillator. And what a defibrillator does is it sits in your body. I did get one, and it's right here. It looks really huge there, but it's about like this big, and it sits right here. And it has wires that snake through my blood vessels and screw into my heart. And it basically constantly monitors me, and it's like having people following me around with paddles. And if I go into sudden death, it will shock me, and that'll be great. And I won't die. It's very exciting. So all that is pretty well and good. The electrophysiologist that I saw when I told this has a bunch of these in his desk drawer, just sort of so that he can pass it over to patients, because I think when you see how little this device is, it doesn't feel so scary. So he pushed it over the desk at me. I'm sitting there with my mother, and I pick it up. He's like, "Pick it up, see how light it is." So I pick it up and I say, "Cool, what does it run?" To which I got a blank look. My mother gave me a blank look and sort of said, what are you talking about? And I said, well, I just, obviously this piece of equipment is only as good as its software. I mean, it relies on its software to know when it is that I've gone into sudden death, whether it's, I've run across the street when I shouldn't have, or I decided to run a marathon, or for no reason at all. I'm totally relying on this software to know when is the appropriate time to give me a shock and when it's not. When I need pacing, maybe, or when I don't. And the electrophysiologist, of course, had no answer at all. He said, nobody's ever asked me this. I've never thought about the software on this device. Hang on, there is a representative from Medtronic here in our office today. I will get him because he's the manufacturer, and surely they have thought about this. So in walks this representative, And I sort of explained, I'm a lawyer at the Software Freedom Law Center. I care about the software on my device. I just want to know, how does it work? What does it run? Can you tell me? And he said, nobody's ever asked me that before. So we had this really interesting conversation, and he said, I see that this is a very serious issue. Here's my number. Call me, and I'll put you through to people to talk about this. So emboldened by this, I went and I called him at Medtronic, and he gave me the tech line. And so I called, I kept leaving messages. Eventually, I kept being bounced around, and nobody would talk to me about this. I called the other two major medical device manufacturers, Boston Scientific and St. Jude, and neither of them could give me real answers either. Eventually, I started calling and saying, look, if someone would let me look at the software, I'll sign an NDA, really against my principles, because I'm a nonprofit activist in the technology world. I don't want to sign any NDAs that will prevent me from sharing what I find with somebody else. But I thought, at least I'll be able to see the source code, and I'll feel comfortable about what's being put in my body. But unfortunately, I was brushed off. I was told no. I talked to some people at Medtronic that were sympathetic. They made sure I had access to good doctors. People said, we're Medtronic. We care deeply about making sure that there are no bugs in the software that we put on these devices. Obviously, we wouldn't release it if we didn't think it was safe. All these things. You must trust us. Doctors say, well, actually, the Food and Drug Administration, the FDA in the United States, approves these devices. So, clearly you're overreacting. And when I was talking to that same electrophysiologist on the phone and said, I'm really troubled by this because, I think about all the people that have these devices. Some of them are quite powerful. Dick Cheney had one at the time. He has a more impressive device now that actually continually circulates his blood, so he has no pulse. It's a fascinating device. Yeah. There are a lot of prominent people. The demographic that gets these devices are often in some powerful positions, and so you could easily imagine a situation where someone would be wanting to shut down these devices. And the electrophysiologist that I spoke to on the phone got so upset. He got so upset that he hung up on me. He said, I think you're up to something. I don't understand. I don't know why you're so upset about this. If you want to get a device, I'll help you. But I just think you're hang up. And I think it was very scary because he told me at the beginning of talking to him that he installs these devices all the time. He installs devices, sometimes several devices a day. So, the idea that he could be not even asking questions about the software that runs on these devices was pretty terrifying to him. So I put the whole thing off. And I just said, I can't think about this. It's so terrifying. Am I really going to get proprietary software in my body? I don't know. Plus the whole mortality thing and getting a piece of equipment sewn into your body it's just, it was really a lot to deal with. So I kept putting it off, and eventually I couldn't anymore because friends and family just kept asking me about it and saying, we're so worried about you. We know that you can die at any time. My mother, I of course don't have a landline, and I don't have great mobile reception in my apartment. And my mother, if I didn't call her back within an hour, would start calling all my friends, saying, have you spoke to Karen today? Do you know if she's okay? I went to brunch with a friend, and she asked me how this process was going, and I said, well, nobody from the medical companies is calling me back, and I'm sure I'll work it out. And she just burst into tears, and she said, you could die today, and I just can't deal with that. If you don't take care of this, I don't know if I can be friends with you because this is a serious thing, and you're ignoring it for what she considered to be an esoteric issue. So I really understood that, and I really didn't have a choice. So I got a device. I got it implanted, and it took some time to it took some time, just to recover from the surgery, and also to just to really think about my own situation in a more abstract way to do some research. But I swore that if I got the device, that I would do some research and I would write a paper and I would sort of talk about the issues that came up that the medical profession, or at least the medical professionals that I dealt with, were had no answers for. So the things that I found out when I wrote my paper were things that would surprise you and things that would not surprise you. So software has bugs. I really, really, really wanted to get a picture of the crickets that were in my room last night that fellow keynoters.
Cockroaches.
They are cockroaches? These are cockroaches. But Paul and Jake got them out of my room, so that was very exciting. So we were joking that I was going to talk about real bugs instead of software bugs. But so software has bugs, and medical devices, as Matthew Garrett said, UEFI, will have bugs because the Software Engineering Institute estimates that there's about 1 defect per every 100 lines of code. So even if a majority of the bugs are caught in testing, even if 3/4 of the bugs are caught in testing, that's still a lot of bugs. There's a study that I read that looked at recalls of devices that were published by the FDA. So basically, this study looked at all of the recalls and determined which ones that they could tell were from software failures, and then they evaluated those. And the ones that they could tell enough about what the problem was from the software, 98% of them would have been detected with simple all-pairs testing. So, I mean, basic testing that you would expect for any kind of technical piece of equipment. So, yes, the FDA has some review over these devices, but if the companies aren't doing basic testing, what are we doing? So, software has bugs. We know this here in this room. Another thing that most of us here know is that security through obscurity doesn't work. And this is something that seems really counterintuitive for the folks that are not in this room. Every person who I started talking to about this in the medical profession said, but I don't understand. Why would you want people to be able to see the software? If people can see the source code, it will be that much easier for them to break into it. But as we all know, that's not quite true. And in fact, by publishing the source code, everybody can see it and it'll be a lot safer. But this is a major point that actually I address in my paper, Killed by Code, which goes systematically through a lot of the research that shows how security professionals agree with that assertion. So what we have is actually the worst of both worlds. We have closed code, so it doesn't have the safety of having a lot of people reviewing it. But we also have no security on these devices. So a lot of these devices are broadcasting wirelessly. That's the standard right now. When I found out about that, I was totally freaked out. What do you mean my heart device is going to be continuously broadcasting? Like that just, I mean, thinking about the conferences that I go to, the people I hang out with, I don't want my information being broadcasted. So this is one of the things I brought up with the different doctors that I spoke to. I actually, as you might imagine, I got rid of that electrophysiologist that hung up on me, and I went from cardiologist to cardiologist to find someone who really understood these problems, or at least understood why I was so worried about them. And I finally found a great cardiologist and a great electrophysiologist who said, I have never thought about this issue, but I understand why it could be a problem. You need this device. You can't wait another day, but I'm going to work with you and see ways that we can at least address some of the things that you're worried about. So one of the things that my electrophysiologist did was that he called around from hospital to hospital until he found an old device. So he sort of said, okay, I've got a really simple heart condition. All that I need to do is to have a device that's going to be monitoring for a dangerous rhythm. And if I get a dangerous rhythm, it will shock me. It's a much more simple algorithm than what the newer devices do. So a lot of the newer devices have these complex pacing algorithms for people who have a wide variety of problems. You understand why the medical device companies do this. They do it because single devices, these devices are very difficult to make. They're precision manufacturers, and if they can get these devices that work for a broader range of cases, then that's all the better. And then you never know what kind of additional complications that people are going to be developing. So I don't have any symptoms now, but I might develop them, and it's great to have the pacing technology. But my electrophysiologist, my cardiologist said, great, I know that you have a very simple need here, so why don't I find you an old device? So I actually have an older device that communicates using magnetic coupling, and not through wireless technology, but my father has a wireless enabled pacemaker, and when he walks into a room and the technician's office, they just change his pulse. So, before he even sits down, they know so much about him, and they have the ability to really affect him. It's incredible. But as you can see at the last point on this slide, these devices have been hacked. A university think tank, actually a think tank of a couple of universities, worked together and showed that using just commercially available equipment, you could hack into these devices and take control of them. They were able to not only deliver shocks, which is terrifying. I once had my device shock me in error, and I can tell you it's like being kicked in the chest. You are basically, you're out of commission at least for a few minutes. I had to sit down, and it was so exhausting, just the surprise of it and the worry that I went to sleep for a few hours afterwards. It's pretty unnerving. And so not only that, they were able to deliver those shocks, but they were also able to stop the delivery of treatment. So if the device was pacing, they could stop the pacing, and a lot of people require their pacing in order to just live. So a lot of people can't walk up a flight of stairs. My father's one of these if his pacing is disrupted. They were also able to get key information off of these devices, like medical ID numbers, doctors' names, serial numbers, a lot of personal information that's broadcasting, and there's no encryption of any kind on these devices. So it's pretty scary. They were also able to put these devices into test mode, and what that does is it slowly runs down the battery, or runs down the battery at a much faster rate than under normal circumstances, and these devices are only as good as their batteries. So if my battery runs out in my device, I need a new device, which is surgery. So these devices have been hacked. It was after I was diagnosed that happened, but then I called up the doctors and said, see? So the doctors really rely on the fact that these devices are approved by the FDA in the United States and similar regulatory bodies elsewhere. And so as a good lawyer, I went and researched the FDA mechanisms for approval of software. And what I found is that the FDA doesn't even typically review the source code on these devices. They don't, unless there's something obviously wrong with the software, they generally don't even ask to see it. There isn't actually a clear set of requirements for the software even. And the reason why, there are reasons for all of these decisions at the FDA, but we think the FDA is doing a lot more than it turns out that they are. The fact that they don't have a clear set of requirements is connected to the fact that they say that the companies that design these devices, because they're so specialty and because they're so particular to each manufacturer, there are probably tests that are specific to those devices, and that the people who know those devices best are the manufacturers. And therefore, they're the ones that need to design what the tests are. And there's some back and forth about whether they've done the right tests or not, but the truth of the matter is, at the end of the day, there's nobody at the FDA that even sees the source code. Because they're not requesting the source code, they don't even have a repository of it. So if there's catastrophic failure at Medtronic, for example, I don't know that there's a canonical repository for the software that I would have access to. And without being able to update the software on my device, I may have to get surgery to get a new one. So, if there's a problem, my doctor, or some, really, truthfully, or some savvy, some programming savvy doctor that I could find would be able to help or work with to write a patch for my device should there be a bug or should we find it out. So I actually spoke on a panel with a guy in cybersecurity at the FDA, and I was really, really nervous because, you know, I did as much. I'm a lawyer. I did all the research I could about the FDA, but I was sort of not sure if this was actually the case in practice. So I put up the slide and I said, you know, John, tell me if I'm wrong, but this is what I think it is, and this is the way I think it is. And I followed it with a slide about free and open source software and why it's so much better and so much safer. And as soon as he came up to speak, he said, everybody thinks that the FDA should do this and the FDA should do that, but we just don't have the resources. And, you know, that is not what the FDA is set up to do. And then he paused and he looked at me just as I was about to sort of, you know, say, and he said, but you're saying something different. You're saying we let everybody else review the source code. That is very interesting. Making sure that our devices are, have software published means that everybody else can review it. I mean, I would have reviewed it. My dad, who has that pacemaker, is also an engineer and a Fortran programmer. He probably would have looked over it. Many of us know people with pacemakers. We would scour that code for sure. One other thing that I found out, which was a little bit weird, is that because these devices in the United States are approved by a federal agency, patients are preempted from suing under state tort law. So there's a whole avenue of remedy that patients normally get, which the medical device manufacturers don't even have to worry about. So now, I mean, I'm not saying that the medical device companies don't care if their patients die. Obviously they do. But there's a whole part of legal remedies that aren't even available. Really amazing, this research, and all of it is set out in this paper I wrote that's available on the Software Freedom Law Center's website. So all this results in the fact that I don't have freedom in my own body. I'm not allowed to review the software that is implanted in it. It's literally connected and screwed into my heart, and I can't take a look at it. It's unbelievable to me, and I still, my mind is blown at the fact that this situation happened to me. I mean, it's a little bit freakish that I was a lawyer at the Software Freedom Law Center and I happen to have this rare heart condition, I admit, but still just mind-blowing. I didn't even have a choice. The choice was either you are extremely likely to die or you can get this device in your body. I hope that nobody in this room has to face that choice, but it was really, really, really scary. And then I started thinking about it. And you know, it's not just our heart devices. It's anything that our lives and our society rely on. And as I thought about it, I realized that this actually touches on a lot more areas of our lives than I thought it was. For example, cars. Yeah, so like the university think tank that worked on those medical devices, and I would say if you have time and are bored, you should totally read that study. It's fascinating. They implanted the device into a bag of bacon or meat of some kind to simulate it, and they show all the equipment that you can find anywhere that they used to hack into it. But the same process was done with cars, and a different think tank showed that they were able to hack into two different brands, two different manufacturers' cars. So the IEEE says that a premium class car has close to 100 million lines of code. So if we think back to what the Software Engineering Institute said about one bug for every 100 lines of code, that's a lot of bugs. A lot of bugs just in your car. And what this think tank was able to do was all the things that you might expect. They were able to cause the car to accelerate and to brake. They were able to control each wheel of the car individually. And my favorite part, just for kicks, is that, I don't know if you can see, but they were able to put a message on the dash. And so they said pwned. And there's the little X-eyed emoticon there. So, you know, the idea that they were able to take control over two different brands of premium class cars was, is really amazing to me. Voting machines is another area that is super critical, and that we've actually been talking about, a lot of security experts have been talking about the problems with our voting machines. In the United States, we rely on Diebold and a lot of private manufacturers, we have had problems with calibration. I don't know if you've seen, but there are all these hilarious cartoons of people trying to vote for the right candidate, and the name of the candidate they want to vote for moving around the screen, and sort of, you're trying to poke after it, and eventually, no matter what you do, it says, so you wanted to vote for you wanted to vote for the opposite candidate, right? And it's very difficult to know. And because we sometimes don't have verification of a paper receipt, we don't even know necessarily that our vote was counted properly, and that we were able to vote for the right candidate in the end. Really weird, as this is the basis of our society and the backbone of our democracy. I love what they did in Brazil. I don't know if you guys heard about this, but Brazil said, we know that software has vulnerabilities and software has bugs, so what we're going to do is we're going to invite teams of hackers to come in. We're going to give you the source code, and we're going to give a prize to anybody who finds a vulnerability to game the system. And of those teams, 2 of them were able to find bugs. They say that neither of them would have affected an election, but they were able to fix those bugs, and those hackers got a prize. Democracy is safer. Security through obscurity doesn't work. I don't know when we're going to figure this out, but Brazil has got it down. So it's possible. Our financial institutions, yeah, it's exciting. Financial institutions are another area. We've seen recently, how bad it can be when our trusted institutions fail. And a lot of these institutions are running software and our stock markets and just the operations of our bank. These are all things that are critical to just the way we live our lives. It's more of a societal thing, but we've already seen that there are vulnerabilities there. So all of this to say, it sounds heavy-handed, but my medical device can be controlled. Our cars can be controlled and interfered with, and our financial institutions can be compromised. So I think we can all agree here that our society and life-critical software must be safe. But we're in a really interesting time right now, because how do we know what software that we use is life and society critical? The way that we use computers has totally changed very, very rapidly and very recently. I've been astounded how people of all ages have started using computers in a way that they never have before. It's no longer specific tech-savvy people that are computing. It's everybody. It's our grandparents. It's everyone, and we're using our software for everything. It's become how we do everything. How we communicate with each other, how we talk on the phone, how we write, how we create art, how we handle our educational institutions, and how we manage our lives. We're building all this infrastructure, and we're not even really thinking about it. A lot of people are using their phones to monitor things like their exercise schedules and their diet. It's very convenient because you're keeping track of what you eat as you go, or what you do. Some phones have pedometer functionality built in, and that's kind of basic and fundamental. But there's already software for the iPhone that can talk to an implanted insulin pump and compare your exercise and your diet information with your blood sugar levels on your insulin pump. So now suddenly we're back to where I was with my medical device. You've got an iPhone that you're relying on for your life. So, we're building all this infrastructure, and we really need to think about it, which is why the desktop is so important. And this is where sort of this all fits into my personal story and why I left the Software Freedom Law Center, which I loved and felt like the luckiest lawyer in the world for being able to work there, and went to the GNOME Foundation, which I also love. But, and I say the desktop in quotes because I am talking about these ways that we interact with our computing and the ways that we manage our lives through software. we've reached the point where software must be usable by everyone. I think everybody here probably knows an older person who, as of a few years ago, probably never did anything with their computer. My mother was one of these people. She, I remember when I was a kid, I kept saying, "But Mom, look at these cool games." Not interested. And then I remember I was in college and I said, "Mom, if we could talk by email, it would be so much better." Nothing. I remember in law school, I was saying, "Mom, I can do all this great research using my computer. I don't have to sit all day in the library. It's awesome." Nothing. Later, I try to say, "Mom, I'm organizing my travel using the computer." Suddenly, she was slightly interested. And now, through everything that has come to pass, she can't do anything without her computer now. Now her computer has become, it's her first thing when she does, she emails and talks to her friends, she does her travel, she manages her finances. It's spectacular to me because, and I don't use my father because he was an engineer, but my mother was really a bit of a technophobe, and now she loves Apple. Loves Apple. She can use her computer to do, she doesn't have to think about it. It's great, and it's very frustrating for me. But I'm excited for her because she now can use a computer, and it's something she owns now. She doesn't ask me questions. Well, she does ask me questions, but she doesn't think that there's any reason why these devices are not targeted at her. And she is very much a representative of the majority of our society. And these are people who only a few years ago would not have been that able to do very much with their computer. So we need to appeal to these people because they are the ones who are making choices like supporting iPhones to put in their exercise and diet regimes to talk to their insulin pumps. These are the kinds of things that we need to really worry about because if we can't make our software easy to use by everybody, no one's going to want to use it. And we have an opportunity now, a window that is slowly closing, because we're making choices now that we're going to have to live with a long time. We're building habits, we're building expectations, and we're establishing the metrics in our society for what is acceptable software and what isn't. So I'm not going to read these to you. You guys are here at Linux.conf.au. You know all the awesome reasons why you should use free and open source software. You're here for all those reasons, including that it's just really fun. And we've been having a great time here learning about all sorts of really cool things. But the underscore of all of that, and where all of these reasons come from, is from freedom. And free and open source software is not just good business. It's also the right thing to do. So when we talk about our heart devices, we talk about our voting machines, and then we talk about the way we live our lives and the infrastructure of how we talk to one another, we see that free and open source software is just the right thing to do for our society. And in order to bring that to other people, we need to make sure that it's easy and clear for them to use. So these are some screenshots from the GNOME 3 release, which most of you, I would say, are probably familiar with already and are forming your own opinions about whether whether GNOME 3 is something that you want to use or not. And I think that no matter what perspective you come from, I think you can see that the GNOME 3 rewrite is done to address these issues. It's to make our software sleek and usable by everybody. I joined GNOME after the GNOME 3 release, and it was the GNOME 3 release that made me realize that I had to go work for GNOME because this is our future. We need to cross the bridge. We need to be able to provide software to people who otherwise, wouldn't be able to use it. We need to make sure our desktops are accessible by everyone because we are not going to be able to build the right infrastructure for our whole society if we don't bring these people on board too. This is a second screenshot. That happens to be Marina from the GNOME community, and she's the head of the GNOME Outreach Program for Women, which is an awesome program, and is the kind of thing you can do in a nonprofit. But what you may not have seen is that we launched very recently an extensions website at extensions.gnome.org, where third parties can upload extensions for the GNOME shell, and it's a simple point and click for GNOME 3.2. So you can install all of this customization. And we're sort of trying to build the ways that GNOME 3 is going to develop over time. And so even though we have a single GNOME shell vision with what I think are great choices, if you disagree with them, there's a way to implement changes. So GNOME, I think many agree. I've actually had a lot of people look at my computer over my shoulder and say, "Oh my God, what is that? That's so great. It's not a Mac, but it looks so good. What's the story with that?" So it's beautiful, but it's a lot more than beautiful. It's nonprofit driven. And in the free and open source software space, we have a lot of different ways that we develop our software together. Some of our projects are more on the Android or Unity side of things, where they're mostly controlled by a single company. And there are communities that build up around that. But at the end of the day, the ultimate control of the project is by a single company. And then we have projects like GNOME that are nonprofit focused. And this actually touches on some of the stuff that Bruce was mentioning in his keynote. What you get for nonprofit development, or having a nonprofit that unifies the development in a community, is a lot. And one of the main things that you get is a key path of trust. So the GNOME community, for example, the foundation is composed of members. I think there are over 300 members. It varies depending on where people are in renewing their membership. But in order to become a member, you have to become a contributor to GNOME, and it's only available to individuals. And if you're a contributor to GNOME, you can become a member, which allows you to vote for the board of directors, which influences the direction of the project, helps provide the infrastructure to support development, and decides to hire people like me, so who are out there advocating for the ideology of free and open source software and helping to organize this kind of effort. So if you imagine a situation now, the GNOME community does not require copyright assignment, but if a nonprofit community like the GNOME community were to require copyright assignment, were to accept copyright assignment, those copyrights would be held by a foundation that had oversight by the contributors, by everyone who has a stake in the community, by everybody who invests in it. There's a certain assurance to knowing that the control of a community is in a nonprofit that is focused on what the contributors want diversely over companies. I did put in saying that it's, I wanted to stress that I'm not saying that companies shouldn't, don't have a very, very important place in free and open source software. Of course, companies, must be able to develop products in the free and open source software community, but we need to encourage these nonprofit structures which are focused on the ideology and work with companies to help them accomplish their goals, but under the rubric of nonprofits, the way that we have in the GNOME community. We have a lot of companies that are involved in GNOME in the advisory board and just as good participants. But the overall mission of the GNOME Foundation and the community is the public good. We are a public charity. So we are focused on the public good, not on our profit. Which means, we care about our profit, but for participants in our community. But what it means at the end of the day is that we want to make the world a better place. It sounds a little bit hokey, but let's be honest, that's where a lot of this free and open source software came from originally, ideologically. That's why we have such great and cool software. We have to start thinking about making the world a better place. So we at GNOME recently launched an accessibility campaign. We want to make 2012 the year of accessibility. This is a perfect example. Yeah, it's really cool work. It's super important. So this is exactly the kind of thing that a company might not be able to afford to do. Because it's not necessarily in interest in increasing the bottom line to work on specific accessibility initiatives for smaller populations of people. But we at GNOME understand that this is incredibly important because a desktop that's not usable by everybody is one that fails our mission. So this guy is Robert Cole. He is super awesome. That's a picture of him and his family. He was kind enough to come forward and let us use a testimonial of his for our accessibility campaign. He was born with a vision defect, so he has no vision in one eye and very limited vision in the other eye. He was relying on some proprietary assistive technologies at one point that were really working for him. He got a grant from his local government in order to get those technologies, and they were assisting him to work. But then when his system upgraded, he applied for more funding to get the upgraded assistive technologies, and he was denied additional funding. And he was just out of luck. Fortunately, GNOME has been a very accessible desktop, and he was able to use GNOME technologies, and through that he became a very active member of the GNOME community. But with free and open source software technology, whatever we develop is going to be out there, it's going to be available. You don't have to rely on expensive proprietary upgrades to know that you're going to continue to be able to use your software should your overall system upgrade. So, making sure that this kind of work is done in a free and open source software environment is extremely important. So we've just launched this accessibility campaign. If you donate to GNOME while this campaign is going on, we pledge to use the money to develop assistive technologies. So all this to say, let's choose freedom. We can choose freedom. We in this room are a very special group of people. While I'm focusing on, what our users are doing and how we must bring our users, and I say the broader users, we have to think big, we have to think giant. And while we need to do things that bring our user base in, people in this room are making choices every day. I can't tell you how many iPhones I have seen at this conference, how many Macs I have seen in this conference. We have the technology, it's good. I don't really tweak my desktop very much anymore at all. I switched over to GNOME Shell, and it's so sleek and great that I barely use the command line for things that are connected to my computing environment, and only then when I really feel like it. It's not for everybody, but we need to choose free and open platforms. We need to develop on them because it's the only way we're going to create these, safer and better societies. It's the only way we're going to create a world where we know that our software can be reviewed and that it will have integrity. We need to build our communities in the nonprofit space because we need to create those really good degrees of trust. We need to bring the ideology back into free software. It's, I'd say it's going a little bit out there to say it's not about terminology, it's about ideology. We really need to think about making the world a better place because we can, and we should. I have this picture from the original Apple campaign because it really strikes me that this woman coming and taking her hammer and flinging it against the establishment and the machine for our individuality and our freedom. And it really speaks to me now. Let's choose free and open source software for ourselves and for our society. So the GNOME Foundation is a charitable organization. We accept donations, and my talk is freely licensed, so feel free to quote it and republish it. Does anybody have any questions?
Good day. I guess I personally see it as a really positive future because I think there's never going to be the year of the Linux desktop where everyone suddenly converts, but it will just be this gradual process in the same way that most of us have come to Linux after some other proprietary process. So I guess I'm wondering how you see us engaging with not the entirety of society, because that's way too difficult, but what's the next edge of the people that we can engage with that can then convert their friends and their parents and so forth?
I honestly think that the next wave is that we need to get into schools as much as possible. I think there are a lot of great initiatives to bring our various free distros into schools. What really strikes me is that in the United States in particular, there are a number of nonprofits that are set up as technology charities, and what they do is they bring Microsoft licenses and other proprietary licenses to underprivileged communities and to schools. And they get tax breaks for doing that. What they're actually doing is creating a dependency on proprietary software. And it's a very clever, very, very clever technique because we're training people to use certain kind of software. We need to do the same thing. So I know there are a lot of great initiatives already. GNOME has a number of initiatives that we do this. And I'd say everybody get involved in your community and start bringing our software into schools. I think that's the first step. I think the next step is writing really cool applications for our free and open platforms. If we've got the next cool thing, then people will want to use it. There are a lot of different steps. I think you're right. There's no easy answer to make this the year of the GNU Linux desktop. It's just not going to, it just doesn't happen as easily as that. But there are things that we can do in schools is, I think, the first place we should start.
Thank you. Two things, if I could. One is, for us in Australia and other countries, if the FDA has approved it, is that it? Is it accepted here without us having our own standards and rules, seeing the software, any of that?
So I haven't actually looked into Australia. I should have. I actually thought this morning that I really needed to check what the situation is in Australia. But I did look in. I know that in the UK and other countries there are comparable bodies. The ones that I've looked in so far also don't review the source code. So they have similar review processes. The FDA only applies in the United States. So each region has its own approval process. But from what I've discovered so far in the regions that I've looked at, they're similar.
The other thing is that there are other areas where software is extremely important that you've mentioned during your talk, like avionics and gambling machines and so on. And in some places in the world, there are different rules. There's review of code and that sort of thing. So two things out of that. One is it seems a shame that there aren't general government standards for software where it matters. Have you got any thoughts on how we could make that happen?
Well, we have to become real advocates, and what has really struck me is that the proprietary software companies have such an amazing lobby. They have so much money that they can pour into making sure that the government is deeply concerned about their innovative edge on, for their products, that they keep their appropriate incentives. Now, medical devices is a really good example of how that breaks down. When you think about the business case of medical devices, you sort of start to see, okay, well, I'm not buying my I'm not choosing the brand of my heart device because it has the best software on it. I'm choosing Medtronic because they have a good track record, because they are a precision manufacturer of really detailed equipment, and they have been for a long time. If they publish their software, even if they publish their hardware specs, it's not like Nokia is going to go and start producing medical devices. And if they did, it would take some time to get doctors comfortable with the fact that they would be relying on them. They've got good support. So, there's this whole issue of the fact that these proprietary software companies have a really strong lobbying force. The only response I've gotten from Medtronic so far is saying, our business case relies on keeping our software proprietary. In the United States, there were a bunch of breathalyzer cases for drunk drivers, and those drivers, there was a driver who said, if you're going to convict me based on the fact that this breathalyzer said my blood alcohol level was very high, I want to be able to see the source code in order to determine whether or not that was accurately derived. And the company fought it and said, this is our proprietary technology, blah, 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 blah. Eventually the court said you must produce the software, the source code, and what the court found through experts was that the results could not be relied on. So, amazing stuff. And this happened in a lot of different jurisdictions. Some in the United States, some jurisdictions say you must produce the code, others say no. But I think at the end of the day, we need to keep this in our dialogue, keep asking these questions throughout our different areas, from breathalyzers to medical devices, and being a really vocal community about these issues is going to help. We also need to organize from a lobbying perspective as well, because there's just so much funding on the other side. There was a question back there. Oh, you've got the mic, Jake, okay.
Hi. So first of all, I think your talk was totally awesome, and thanks for expressing basically the core of the free software ideology, which is that free software is about freedom, including the freedom to know how you're kept alive, which I think is really important. So thanks for doing that. And as far as the remote car exploit stuff, that's actually from Alexei, Carl, and Franzi in the lab at UW where I work. And those exploits were done remotely through the telematics units in the cars. So just like hard implants, people can crash your car remotely. So this, I mean, and it's like through a telephone.
Yeah, I meant
so
to.
That's really important.
I meant to get that into a little bit more detail, but yes, the control of the cars were remote. I also wanted to mention the HP printer exploit that happened recently, where over the internet, folks were able to take control of HP printers, which not only were able to do all kinds of terrible things like be able to know what you're printing, including monitoring to see if you're printing tax documents, and if so, determining what information was included in particular boxes, but they were also able to set printers on fire. They weren't?
No.
They were.
There was a guy at the CCC that set a paper on fire this year.
Yeah.
He lit the paper on fire.
But he hacked, as far as I understood, he hacked the temperature control unit in hardware.
I don't think so. He did it with
You should either
Anyway.
talk in the microphone or ask a question.
So the question I was going to ask you is, you're talking about accessibility, and one of the things I've noticed is that people that are blind are totally fucked when it comes to using computers. And if you want to get a Braille terminal, it can cost somewhere like 6,000 or 8,000 euros to get them. And there's one group in the UK that's looking at building affordable ones, I think coming in somewhere at $1,000. But I wonder what GNOME can do to make it so that computers are really accessible in terms of alternate methods of interfacing with the computers, especially for people that are blind or unable to see. And I wonder if you could talk a bit about Braille terminals and maybe making them accessible and so on.
Yeah, I was going to say this actually is a separate talk. There was a talk on accessibility at this conference, but I don't want to get into too much detail about the particular initiatives. But with GNOME 2, there were a lot of assistive technologies for vision, a lot of magnification, and other types of software that were very helpful. But and actually, GNOME won several awards for the accessibility of their desktop. But while we rewrote GNOME 3, we actually broke a lot of our assistive technologies as part of the necessity of starting all over again and starting new. So actually, our campaign is much more basic than that. I'd like for us to get there over time, but we have some great software, but it needs help just to get working. So the accessibility campaign that we're running now is really fundamental. If we get a huge level of support from it, we can hire developers to work on this stuff, and we can start exploring some of those particular initiatives. But it's sort of like now, the accessibility team at GNOME at our annual general meeting, I asked them to give a little presentation of where we stand, and the first slide was a set of stairs. So right now we have a lot of work to do. We need to bring our new system back to where we were with GNOME 2, and then we need to go beyond. We're much further now with GNOME 3 than we were when we launched GNOME 2, and GNOME 2 went really far, but we really have a long way to go. So there was a question from someone right over there who had put his hand up straight away, and
if we can
I'll be
have
really,
one
really
more
fast.
question, we'll have to wrap it up after that.
Thank you. I am concerned that should your implant fail and you collapse to the floor, I don't know what to do. Is it just CPR, or is there something else I should do, and how is that
That's a
communicated?
great question. That's a great question. Everybody should be trained in CPR, and I became aware of this and asked all of the people close to me to get trained in CPR when I found out I had this heart condition. So if somebody collapses in front of you, you should commence CPR. You should check their life signs and follow that procedure. For me, if I collapse now, my device will most likely shock me. And if it doesn't, if somebody performs CPR, hopefully we can get my blood circulating until help comes and I can be shocked with an external defibrillator. The truth is, that it often takes so long to get an external defibrillator and to get people's heart started again that there's often some brain damage by the time that happens. So that's part of the reason. Huh? There's one in the lobby, yeah, a lot of, and it's funny because when I walk by those now, I think those are for suckers. I've got my own. So, all this to say, I am really glad that I have this piece of technology, and I'm glad that I can rely on it. I just think it can be better and safer. Okay, thank you.
Unfortunately, we are out of time, but a huge round of applause for Karen. Thank you.